Why vMotion works without shutting down the VM. The hidden magic behind live VM migration in VMware. What if I told you VMware can move an entire running server to another physical host without shutting it down? No reboot, no disconnect, no outage. Applications keep running, users keep working, and most people never even notice it happened. So how does VMware pull off what seems impossible? Let's find out. vMotion is VMware's live migration technology. It allows a running virtual machine to move from one ESXi host to another while applications continue operating normally. But here's the important part. VMware isn't moving a file. It's moving the live state of an entire running computer. And this is where the real magic begins. Here's the problem VMware engineers had to solve. At first glance, moving a VM sounds simple, but there's a major problem. The VM's memory changes every millisecond. The CPU is constantly executing instructions, and users are actively connected. How do you move something that's changing every second without stopping it? That's the real engineering challenge. And solving this challenge starts with preparing the destination host. Before VMware moves anything, it performs several critical checks. VMware prepares the destination ESXi host. CPU compatibility is verified, networking is checked, storage access is validated, and resources are reserved. Think of it like preparing a new apartment before the tenant moves in. Everything must be ready before the move starts. Once everything is ready, VMware starts copying memory live. This is where the actual migration begins. Now the migration begins. VMware starts copying memory from the source host to the destination host, but the VM is still running during this process. Users remain connected, applications continue working, and new memory changes keep happening while VMware is copying. But there's one major complication. And this is the biggest challenge in the entire process. As memory is copied, applications continue modifying RAM. These modified memory blocks are called dirty pages. Instead of starting over, VMware simply tracks the changed pages and copies only those updates. This keeps the migration efficient and fast. So how does VMware keep up with these constant changes? The answer is surprisingly clever. VMware now repeats the process several times. The first round copies most of the memory. The next rounds copy only the pages that changed. With every cycle, the difference between the source and destination becomes smaller, until both are almost perfectly synchronized. But eventually, VMware reaches the final switchover moment. This next step is the reason users rarely notice vMotion. The VM pauses briefly, usually for just a few milliseconds. The final memory updates, CPU state and network state are transferred. Then the VM immediately resumes on the destination host. For most users, this pause is too small to even notice. But even after moving hosts, the VM must keep its identity. So why doesn't the VM lose its network connection? Even after moving hosts, the VM keeps its identity. The MAC address stays the same. The IP address stays the same. Network tables are updated automatically, allowing active connections to continue uninterrupted. To the network, nothing appears to have changed. And shared storage makes this process much faster. Here's the hidden reason vMotion is so efficient. VMware usually doesn't move the VM's disks. Both ESXi hosts already access the same data store through SAN, NFS, or vSAN. Since storage stays where it is, VMware only needs to move the live running state. But storage isn't the only compatibility requirement. There's one more problem VMware must solve before migration. There's another requirement. The destination CPU must understand the same instruction set as the source CPU. Otherwise, the VM could crash after migration. VMware solves this using Enhanced vMotion Compatibility, or EVC, which presents a common CPU feature set across the cluster. But what happens if migration fails completely? So what happens if the migration fails halfway through? VMware immediately aborts the operation. The original VM continues running on the source host exactly as before. No split VM, no corruption, no lost workload. VMware always protects application integrity first. This reliability is exactly why enterprises depend on vMotion. This is why vMotion became one of VMware's most important technologies. This capability changes how data centers operate. Administrators can perform hardware maintenance, balance workloads, and automate resource optimization without taking applications offline. Without vMotion, many routine infrastructure tasks would require downtime. Let's look at how this works in a real enterprise environment. Here's a real-world example happening in data centers every day. Imagine an ESXi host that needs maintenance. Instead of shutting down hundreds of virtual machines, administrators simply migrate them live to other hosts. Users continue working normally while maintenance is completed behind the scenes. This happens every day in enterprise environments around the world. Now let's put all the pieces together. Let's recap the entire migration process in under 30 seconds. VMware prepares the target host, copies memory live, tracks dirty pages, synchronizes changes repeatedly, performs a tiny switchover, transfers CPU and network state, and instantly resumes the VM on the destination host. That's the secret behind vMotion, a perfectly coordinated live state synchronization engine. And now you know why VMware can move a running VM without shutting it down. And that's the magic behind vMotion. The next time someone says, it's just VM migration, remember, VMware is relocating an entire running computer in milliseconds. If you enjoyed this deep dive, hit like and subscribe for more VMware architecture breakdowns. And in the comments, tell me which VMware topic you want explained next. See you in the next video.